This is PSAT 10, Practice Test 2, the NMSQT PSAT test. Practice Test 2, this is the hard module, question 19. And it gives the answer here, and it's got an explanation. You can read that explanation and work it out that way, and it gives two alternatives. But I'm going to show how to do it a different way. It says if k minus x is a factor of the expression negative x squared plus 1 over 29 nk squared, where n and k are constants and k is greater than 0, what is the value of n? Well, first of all, and I'll just write this here on Desmos. I've already graphed it, but I'm just going to start from scratch. If k minus x is a factor, and for some reason my caps lock was on, k minus x is a factor. Remember, in order to get the x values of the zeros, you set the factor equal to 0, and then I would add x to both sides, and k equals x. So x is equal to whatever I choose for k. So remember that. I'm going to, I would just leave it written in, but I don't want it cluttering this thing. So I'm going to write this equation, negative x squared plus 1 over 29. I put 2n for some reason, and I think it was nk squared. So now it's going to set up a slider. And okay, it's already given me a value for n and k. The question states that k has to be greater than 0. Well, k is equal to 1. And remember again that x equals k. For the zeros, x has to equal k. So I've got to get this graph to where it crosses the x-axis at 1 and negative 1. I mean, it's centered around 0. I can see that in the image. So notice, first of all, if n is negative, n is a negative number, it doesn't cross at all. It has no real solutions. So right off the bat, just by seeing that n can't be negative, a and b are out. So now is n 1 over 29th or 29? Well, 1 over 29 is less than 1. And I can see that even at 1, even at 2, even at 5, it doesn't cross at 1 and negative 1. X doesn't equal k at the zeros, at one of the zeros. So the answer has to be 29. And I'll just double check it. I will change this by putting 100 in there. You just click on it, and then you can set the range. I changed it, and I'm going to put 29 there. And now notice, x is equal to 1 and x is equal to negative 1 are the zeros. So I get my factor, x equal 1 is a factor, which would be x equal negative 1. I think I said x equal 1 before the 0. The factor that's, well, let me double check it. 1 minus x, yeah, 1 minus x, oh yeah, it's x equal 1. I was right the first time. So the factor that is k minus x, or 1 minus x, if I set that equal to 0, and then add x to both sides, x equal 1, and I only get that when n is equal to 29. And now watch this. Even if I change the value of k, let's say I change k equal to 2.7, notice that still negative 2.7 and 2.7 are the zeros. So n has to be 29 in order for the zeros, the x value of the zeros, one of them to equal whatever value k is there. So again, you can do all the work that they show or just set this up. And you do have to remember how factors work. This one's written backwards to what you normally see. Let's say x minus 7 is a factor of an equation. You would set that equal to 0. You'd solve for x. X equals 7. So this one is backward. It says k minus x is a factor. Set that equal to 0. Solve for x. K equals x. And again, k was equal to, in this case, 1. It just had to be greater than 0, so I left it at 1. So in order for x to equal 1, I needed n equals 29. And let me see if that's still there. I got to get rid of these because these are cluttering everything up. That was just examples. And that's an example, that's an example. And so there it is. In order for one of the zeros to have x equal 1, I needed n equals 29. Much easier to do it on Desmos than to do all that calculating work. Just remember how factors work. That's it.